Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to look at quality of service implementation techniques. We'll be discussing avoiding packet loss, quality of service tools, classification and marking, marking at layer 2 and layer 3, types of service and traffic class field, DSCP values, class selector bits, trust boundaries, congestion avoidance, shaping and policy, and finally, quality of service policy guidelines. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. When we have congestion on our network, we're going to get packet loss. Because there's congestion, data just gets lost, it gets deleted because it waits around so long, it gets deleted, the packets become lost. TCP adjusts to network congestion on the fly. When it sees network congestion, when TCP sees network congestion, it reduces the window size. So the amount of data it sends in a packet is smaller. Because it's smaller, there's less data, there's less waiting time, there's less chance that we're going to have the packet loss. Now, there's a couple things you could do to alleviate packet loss with this congestion. You could increase link capacity. You could upgrade your fast Ethernet switch, that's 10100. You could increase that up to gigabit ports. Same thing with your routers. You could buy a more current router that has gig ports on it instead of 10100 ports. You can guarantee enough bandwidth or increase buffer space. So we can get a higher bandwidth, and that's what we talked about, getting those gig connections in there. When all else fails, you could drop the lower priority packets before congestion occurs. Now, what's the lower priority? It's the static web pages that are traveling across your network. It's email being delivered. What happens if your workers go to a web page and it doesn't load in? Well, they're going to sit there for a couple seconds, then hit the reload button. Have they really been disrupted? Probably not. But if your voice or video starts going, your end users, your employees, they're going to have a bad experience. When we look at quality of service implementation tools, there's three broad categories. First, we have classification and marking tools. Next, we have congestion avoidance tools. And finally, we have congestion management tools. First one here looks at classifying our data. Second one is these tools are going to try to avoid any congestion before it happens. And then the third one, congestion management, we have congestion, how are we going to manage it? Underneath the classification and marking tools, this is where session is classified. This is where you set up your classes. This is where we say, okay, this is voice, this is video, this is high priority, this is financials, this is medium priority, this is web traffic and email low priority. The packets here are also marked. So in the frame header, in the packet headers, we go in there and we mark it for high or whatever the quality of service is. Underneath congestion avoidance tools, the traffic classes here, the ones from the classification and marking tools, these are allocated the different network resources that they need. Now, some traffic may be dropped or delayed or remarked to avoid congestion. And so we're thinking ahead saying, okay, we might have congestion here. What can we do? We can drop some of the low priority stuff. We can delay, we can buffer the web traffic and the email, or let's remark something to get it through our network a little bit faster. We also use weighted random early detection. And this regulates our TCP traffic, looking at efficiency in our bandwidth before our queues get full, and then we start getting overflows. When we get overflows in our queues, that's when we start losing data and we start getting packet loss. Under congestion management tools, this is when traffic exceeds available network space. Your network is full, then we're going to start looking at maybe we're going to queue traffic. until our network is available. Now, common Cisco IOS-based congestions include class-weighted fair queuing, and it also includes the low latency queuing algorithms. Those three quality of service tools, they work together. And the order in which they happen is we do the classification and marking first. Then we do congestion avoidance, and then we get into congestion management. When data comes into our router, when it comes into the ingress port, this right here is data coming in. And you could consider this whole thing here, this is our router. This is what is doing our quality of service for us. So it comes in the router. This data is all random. And if you notice, it's gray here. It hasn't been classified. And so what we do is we start looking at that. Once we classify it, we then mark it. And we say, okay, this is high priority, low priority. Notice how classifying here, all of this was gray. Then when we got to marking, we put some colors to it. We put it in, or we identified them as their classes. Once our traffic is marked, then we go into the congestion avoidance phase. The traffic here is put into queues. All the blue is put up here, and we're guessing this is high priority because it's on the stack. All of these packets are placed in this queue. When in this queue, we're going to be looking at the different policies here, and we're also going to be assigning resources. If our queues get too full, so this queue is filling up here and it's overflowing, this is where we could selectively drop some of this to avoid our congestion. Then we have our congestion management. This is where our packets are placed into queues according to their classes. And then based upon their classes, they're scheduled or shaped depending upon what quality of service models you're using, or different policies that have been applied, and then it's sent out our egress port or the outbound interface. Before we can apply a quality of service policy to a packet, we have to classify that packet. We need to say, is this high priority, medium priority, low priority? You may have more than just those three classes. You may have 6 classes. You may only have 2. Whatever works for your company, but you need to classify your packets before we can apply those quality of service policies to that. Classification depends upon your quality of service implementation. We can do classification at layer 2 and layer 3. We can use interfaces, access control lists, class maps to all go in and classify and mark our traffic. We can also classify traffic at layers 4 to 7, and that would be using network-based application recognition, meaning your software you're writing, they can go in and manipulate the data in your packets to prioritize your traffic according to quality of service. If we look a little closer at traffic marking, we can see that marking happens at layer 2 and layer 3. At layer 2, we have our quality of service. Now, this is dealing with Ethernet with the 802.1q trunking and the 802.1q quality of service. Traffic marking at layer 2 is only available to the local LAN because you're using your layer 2 switches. With Wi-Fi at layer 2, we use the Wi-Fi traffic identifier to mark our traffic. With MPLS at layer 2, we use that experimental field. At layer 3, with IP version 4 and IP version 6, we use IP precedence and DSCP, differentiated service code point. With layer 3 marking, the traffic can go from router to router and be carried end to end across the network. Here we can see our marking at layer 2. We have an 802.1q frame here at layer 2, an Ethernet frame. And what we do is we insert our QoS here into the frame. And so we have the normal frame here. Then we come down here and we insert the tagging right here. This tagging then has 3 bits that are the priority field. This priority field here, that is used for quality of service. This is where we set our quality of service. We set a value in there, and that is used by our switches to prioritize traffic on our local area network. There are 8 cost values that can be set there in that quality of service field. 0 is the best effort, 1 is medium priority, 2 is high priority, 3 is signaling, 4 is for video conferencing, 5 is for our voice traffic, 6 and 7 is for network control. That's reserved, we don't use it. Now, the reason there's 8 values, remember the quality of service, if we look back at this last slide here, had 3 bits. Those 3 bits in binary, when you convert them to decimal, give the values of 0 to 7. We have our 3 bits here. Lowest possible value here is all zeros. The value of this is 1, 2, 4. So all zeros is equal to 0. That is our best effort traffic. If we go to the maximum 0, where we have 1, 1, 1, so we have 4 plus 2 plus 1, that equals 7. That is our top value. That's where we get the 3 bits and the 8 values. And the 8 values over here, 0 to 7. In layer 3, for IP version 4 and IP version 6, it is placed in the packet header. For IP version 4, it is the type of service field here. And for IP version 6, it is the traffic class field. I hope you're liking this episode on quality of service implementation techniques. If you have the time, please leave a comment and let me know what you think of quality of service implementation techniques. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. In the old version, class of service at layer 3 was implemented by using IP precedence and TOS, type of service. IP precedence is 3 bits, the type of service is 5 bits. For a total of 8 bits. You can see here that there are 8 levels, 0 through 7, of the different classifications, which maps to layer 2 class of service. Values 0 through 5, the first 6, give us the different levels of service you are looking for. And once again, layer 6 and 7, that is for our network control. In the current implementation of QoS, we use a 6-bit field for our differentiated service code point, and then 2 bits for our explicit congestion notification. They map directly into those 8 same bits as we did with the old system with IPP and TOS. When we look at comparing DSCP and IPP, we can see that they are still mapped the same. We still have the same values there. And how do we get that? Well, when we did IPP, we did 3 bits. And those values here were 1, 2, and 4. That gave us up to 7 different values, 0 to 7. Now, when we use our differentiated service code point, we have 6 values here. Those values in binary would be 1, 2, 4, 8, 16, 32. And if we look at a value of 101 for IPP, that would be equal to a 1 plus a 4. That gives us 5. So that would signify critical down here. So that'd be 1 plus 4 equals 5. When we look at using the DSCP, we have 6 bits, but we have a 1 where there's an 8, and then we have a 32. That gives us 40. When we look at the DSCP values here in decimal, we see that a 40 is also on that critical. They allowed us to have more different finer control, more different classes using DSCP, but also having it backwards compatible with the IPP, the IP precedence. Since DSCP is 6 bits, there's 64, 0 to 63 different levels of service you can provide. Here's another way to envision the backward compatibility. We have our quality of service, which was 3 bits here. We have our differentiated services code point, which was 6. The class of service here, values 0 through 7. We convert that into binary. That's the first 3 bits. Then we have our class selector and our class selector binary. That's with our DSCP. We can see that these values come out to be 8, 16, 24. And those are the ones, when we look here, it is 0, 1, 0, 0, 0, 0 here, and 0, 1, 0 here. These fields are the same. That's how we make it compatible. When you set up quality of service, marking should happen as close to the trust boundaries as possible, as close to the source as possible. Voice over IP phones, access points, they have the capability of marking your traffic with quality of service, like shown right here with number 1. Traffic can also be marked using layer 2 switches, or it can be labeled at layer 3 using layer 3 switches or routers. As traffic travels across your network, the remarking of that traffic may have to happen. And we can change those IP precedent values or those DSCP, differentiated service code point values. The main mechanism of congestion avoidance is WRED, weighted random early detection. What that does is it looks at how full your queue is, and then it decides what we should drop or how much should we drop. When the queue is empty, up to your minimum threshold, we do not drop anything because there's a lot of space left in our queue. If something happens, our queue can fill up. We don't have to lose anything. Once we're between our minimum and maximum threshold, you start dropping a percentage of your packets. When you're in there, it's like we're starting to get full, you're starting to worry a little bit, so let's start dropping some stuff, just looking to avoid that congestion. Once you break that maximum threshold, we're going to start dropping just about everything at that point. We are going to drop everything we can to get us down below this maximum threshold. Now, what happens once you go above your full queue? This is the buffer overflow. When the buffer overflows, all packets that come into this overflow basically just get lost at that point in time. That's why we try to keep our queues in a reasonable level. Here you can see the difference between traffic policing and traffic shaping. When traffic policing occurs, what happens is any traffic that's coming in above our threshold, and here's our threshold, we just delete it. And what that does is it gives us a cap here, but we still have highs and lows in our traffic. Here. When we're doing traffic shaping, instead of deleting the traffic that comes in above our threshold, and once again, when you delete it, it's gone. Hopefully you have a different retransmit mechanism, TCP or something like that, to retransmit your data for the policing. But when we do traffic shaping, what we do is we queue any data above our threshold and we schedule it later to be sent out. Here in the graph, we have some traffic that went above our threshold. What we do is we take this data, we queue it, and then we send it out at a low point in time. Then when our traffic goes above the queue again, we schedule it to send out, and we continue to do this. We don't lose any data, and then if you actually look at the actual output, you can see that it represents almost a straight line. Yes, there'll be probably some dips in there, but it will be a lot more straighter, a lot more even compared to policing your traffic. As you're thinking about your quality of service and getting your policy set up, there are some things you should consider. One of the big things to think about is that full path from source to destination. How am I making it through the network? What technologies, what policies, what procedures am I using to give me quality of service from source to destination? When we start looking at this, you have to enable queuing at every device in the path between that source and the destination. You have to enable it. Those devices have to do that, either looking at the frame header or part of that conversation that went from end to end. But your devices all need to be quality of service aware so that they can actually do the quality of service. When you go and you classify and mark your traffic, that should be done as close to the source as possible. Close to the source as possible. That way, as that traffic travels across your network, it's been marked. And so we can process it and give it the quality of service it needs. We also should look at shaping and policing our traffic as close to the source as possible. That way it gives an even flow as it goes through that first device onto our network, and then we have an even flow of data through our network. The big burst can be handled at sort of the edge where that end device connects up, but then the traffic on our network was hopefully going to be a little bit smoother, and we don't have bursts. Then we fill up the queues and we lose data that way. It was my pleasure to provide you with this wonderful episode on quality of service implementation techniques. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all of these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.